This
Get the basics
conference will
of.
now be recorded.
Yesterday, we did take a look about the basic aspects of hospital workflow, and we also did see how HL7 message is used in hospital workflow during the various events that are happening in the hospital workflow. And we also did take a look at how the message structure looks like and how to read an HL7 message, and what is the basic structure, what is the syntax of an HL7 message is what we did take a look at. So today we'll see a couple of tools that we can use, and then we'll proceed with the next sessions of how HL7 is a event-driven methodology, what are the various events that we usually encounter, and how what are the names of those events in terms of HL7. We'll be taking a look at all of those things today. So when you go through an HL7 message, when you just take a quick look at it, we did see that a sample message looks something like this. So we have a sample message. So this is a sample message, and going through, if you want to read any specific field, we call out the segment name and then we keep reading the field numbers to go through each one of them and understand which field number has what type of data. For example, we know that PID 5 is patient name, PID 3 is MRN number, PID 3, this is PID 3 is MRN number, PID 2 is patient ID, and so on. But every time counting through this and reading it becomes little difficult. So we have few tools which can break down the entire HL7 message segment wise and field wise. So we'll quickly take a look at those tools, um, which is called as HL7 Smart View. So this tool is called as Smart View HL7 Message Viewer. Okay, you can download it from the very same website, which is called as Smart View. So this is the website. You can go to Smart HL7. You can go to that website, and when you go there, the first one that you will have is Message Viewer. So you can click open that, click on launch and download it. Once you download it, it is free of cost, so you can download that and click on load. When you click on load, you can select the HL7 message and then load that message. Once you load it, on the left hand side, it will show you all the segments. And as in when you keep changing, or as in when you select the segment, it will go ahead and show you all the list of fields that are present for that segment in this message. And it will break down every field for you individually. As we can see here, it is showing PID segment right now. And within PID segment, it is showing up field number 1, field number 2, 3, 5, and so on. 4 is blank here, which is why it is not showing the value of 4. So wherever it is blank, it won't show it up here. So in this way, it is going to show you all the field numbers in a systematic manner. And when you click on certain field on the right hand side, this window of the screen uh, will show only the field level. Then if you select any particular field on the right hand side, it will show the component level. Okay, so each field can have n number of components, right? Like the name has last name and first name, which are two different components altogether. So those components are can also be further broken down in this particular tool. So here it shows component level, and at the bottom it shows subcomponent level in case if there is any component, uh, in case if there is any subcomponent available in the message. So you can use this tool to read the message. Later, once you are habituated to use this, once you memorize or remember all the field names, few of the field names, not all of them. It's very difficult to learn all of them, but there are few important ones which we need to keep in mind, like patient MRN number, patient ID, date of birth, and what is the where do we send patient location, what is the patient class. All of these things are little important, which we need to memorize and keep them in mind because during the process of an interface implementation, we usually talk about these fields. So it is necessary to learn them. In the upcoming sessions, we'll be taking a look at what are the important fields of each segment, so you can understand what to learn and what not to. I mean, what to memorize and what not to. So just download this tool and you can use it uh, for for breaking down HL7 messages. So we have other tools in this as well, like TCP/IP sender, TCP/IP receiver in the Smart HL7 itself, which we'll be using down the line when we implement an interface using our interface engine Mirth Connect. We will be using one of these tools to send out messages, receive messages, and all. So please uh, keep that in mind, and I will let you know when we are ready to download the other tools as well. So we'll continue with the continue from where we halted yesterday. So HL7 is an event-driven messaging methodology. So yesterday we did talk about how we have an HL7 message, which is an event-driven message, and we did take a look at the sample example. So this HL7 standard is written from a perspective that an event that is happening in the real-time world will generate the necessity of data flow from one system to another system. What do I mean by that? Whenever we have an event that is happening in the real-time world, which is nothing but, for example, if a patient gets registered in the front end, patient and receptionist are encountering with each other, they are conversing with each other, and patient is getting himself registered with the system whenever he is entering to the hospital for the first time. So that complete conversation and getting his details saved is called as an event. And whenever patient data is saved in the system, in the PM system, uh, now it has to go and that patient demographic data has to be sent to the EHR system, right? So PM system is one system, EHR system is another system. Saving of patient data in the PM system has generated the necessity of data to go from PM to EHR, which is nothing but initiated the data flow from PM to EHR. It is necessary because doctor will not go ahead and register the patient details again in EHR. So automatically patient details will flow over from PM to EHR and patient gets registered in EHR automatically from the back end itself. And just doctor will be able to look at all the demographic details of that patient. In this way, an event that is happening in the real-time world has been generating the necessity of data to move from one system to another. So these kind of events, wherever the data has to flow from one system to another system, are called as trigger events. Okay. So this is one simple event that we were taking a look at, patient getting admitted or patient getting registered. Likewise, we have many other scenarios in the hospital workflow, which we'll be taking a look at. And each event has its own name from HL7 perspective. We'll be taking a look at them one by one. So now the second, if we broadly categorize the hospital events into groups, then we'll mainly see these groups. First, hospital. uh, patient getting registered, and entire registration related events are grouped under one group. Okay. And then once the registration work is completed, which may include a new patient registration or update of existing patient details if the patient is visiting for the second time or third time, and so on. And then we have appointment schedule. So what is an appointment schedule? After patient registration work is done, we usually schedule appointments on patients. So all of the events which are pertaining to appointments are grouped under one section. And then we have labs. After scheduling an appointment, patient will meet the doctor, and that part is called as an encounter. And doctor will discuss with the patient of what their problem is and all. In case if they are unable to determine directly, then they will go ahead and place an order, send the order to the um, labs. Lab will result back to the EHR system. So anything which is pertaining to orders and results are under this group. And then next we have charges. Once the lab is done, we send out charges back to the PM system. So anything related to charges is under this group. And we also have two other additional events, which are nothing but pharmacies and insurances. So pharmacies and insurances don't deal with HL7. They deal with a different messaging standard. Insurances will deal with X12, which is a claim related messaging standard and completely different from HL7. And pharmacies will have an e-prescription messaging methodology. So these two are different from HL7, so we will not be taking a look at that. But overall, once the patient has walked in, from that point of time till they leave the hospital, which is to generate charges from EHR and send it to the PM system, these are the events that we will have. These are the general terms that we are looking at: registration, appointment, schedule, and so on. However, we have a deeper, from HL7 perspective, we have different names for each of these groups. So let us take a look at them one by one. So when we talk about registration, registration is represented with the help of ADT. A is admit, D is discharge, and T is transfer. Okay. So anything which is related to registration, it could be admission, discharge, or transfer of patient, or update of existing patient details, or changing insurances of a patient within the PM system. All of these things will fall under ADT. And then appointments are represented with the help of SIU. SIU is scheduling information unsolicited. It means that um, appointments are unidirectional. So, which is why the word unsolicited is used. So, unsolicited in the sense unidirectional, which means appointment will flow over only in one direction from PM to EHR. Appointments are never scheduled on EHR and sent back to the PM system. So, that is the significance of the term unsolicited. So, all the appointments are represented with the help of SIU, scheduling information unsolicited. Next, we have labs. Labs are nothing but the orders and results. So orders are represented with the help of ORM, which is nothing but observation request message. And results are represented with the help of ORU, which is um, observation result unsolicited. Orders are represented with the help of ORM, which is observation request message, and ORU is observation result unsolicited. So these two message types are used for representing labs. And with respect to charges, we represented it with DFT. So detailed financial transaction. DFT means detailed financial transaction. So these groups have their own events. So what are they? We'll take a look at them one by one. Whenever there is any registration related event that is happening, it may have two major events. One is a new patient registration, which means patient getting registered for the first time. Second one is update of existing patient details. So let us say, for suppose patient has already visited the hospital but wants to change his phone number or email address or some mailing address or something. So whenever that is the case, we will end up in having two events within registration system. And then we have appointment schedule. Appointment schedule has three major events. Number one would be scheduling a new appointment. Number two is updating an existing appointment with some details like updating comments, updating visit type, updating data, updating other comments, and all of these things, or moving the appointment to a different time. So these are the updates of existing appointments that could happen. And another event that is included in appointment schedule is delete an appointment. So whenever there is an appointment that has to be deleted, we trigger this event. Then the next one is to use charges. Within charges, we have only one event, which is charge information, sending out charge information from EHR to the PM system. And then we have lab related information, which has two major events, that is orders. One is sending orders, other one is receiving results. So again, as I said, each of these have their own names in the regular form that we are seeing on the screen right now. However, from HL7 perspective, the names differ. So we'll take a look at their HL7 representations. So an ADT message is a registration message. As I said in the previous slide, an ADT message is a registration message. And the two events that are involved in an ADT message are ADT A04 or ADT A28, which represents new patient registration. So whenever I see A04 as the event type or A28 as the event type, I clearly understand that it is a new patient registration. And then whenever I see A08 or A31, it clearly indicates that it is update of existing patient details. Okay. So, and whenever we want to read the HL7 message type, then we read it as a concatenated value, which is called as ADT A04, ADT A28, or ADT A31, and so on. We mix both of them and then we call it as one single message type. Okay. For example, if it is a new patient registration, we say it as ADT A04. And if it is an appointment, new appointment, then we say it as SIU S12, and so on. In the same way, same methodology applies for all the other messages, or message types and event types that we have. Next, we have appointments. A new appointment is always represented with the help of SIU S12, and update of existing appointment is indicated with the help of SIU S14, and then we have SIUS 15, which is represented for cancellation of an existing appointment. Okay, then we have DFT, which is detailed financial transaction. So, detailed financial transaction has only one event type because we don't have many more events in detailed financial transaction. We just send out one charge message from EHR system to the PM system. We don't do anything apart from that with related to charges. So it is represented with the help of PO3. Then we have ORM and ORU. ORM is order message, observation request message, and it is represented as ORM O01. O01 is the event type to represent an order. And then R01 is an event type which is used to represent a result, and it is concatenated or mixed up with ORU. So whenever you see a result message, you will see that the message type is ORU R01. In this way, we have all of these different events. So we'll be going through each of these message types like ADT, SIU, DFT, ORM, ORU, all of these message types individually, and we'll be taking a look at what are the important fields and segments of an ADT message. And then next we'll be taking a look at what are the important fields and segments of SIO message. So that will be our learning pattern. Um, so we'll quickly take a look at we'll start with that where we need to take a look at individual message types and the important segments and fields of those message types. All right. So by the end of this session, we will be understanding what are the important segments and fields of ADT A04 message type, and what are the important fields that we need to usually memorize or remember. So ADT A04 or ADT A20, A08 always represents a demographic message. A04 represents a new patient registration, which we have seen just now, and A08 represents an update of existing patient details. Okay, so where do we see it in the HL7 message? If we quickly take a look at this message, where exactly we are seeing that this message type. So here we can see that it is ADT A08. So as I said earlier, always message type has the concatenation of ADT message type and the A08 event type. So altogether we call it as a message type. Okay, so the important segments that should be present in a demographic message are MSH, EVN, PID, PV1, GT1, IN1. And in our previous session, I said that each of these segments have their own names, and the first three letters or two letters of each segment represents the actual name of that particular segment. So in an in a new patient registration message, we have MSH, which is message segment header, and then we have EVN, event segment, PID, which is patient in identification segment, PV1 patient visit, GT1 guarantor, IN1 insurance. So if we observe, each of the abbreviations of each segment represents what kind of data they will have. So the first one is message segment header. We'll take a look at message segment header in detail. So message segment header is like an index in any textbook. Okay, we cannot go ahead and understand the content of the textbook, which without taking a look at the index. If we take a look at the index, we'll get an overall picture of what that textbook has, what are the various chapters present within that textbook, and so on. Right? In the very similar way, each and every HL7 message that is exported or imported into the system will have a message as a mandatory segment. Without a message, you will not see any HL7 message, in fact. Okay, each and every type of HL7 message that we deal with will definitely have message segment header. So what are the important fields of message segment header? One quick note here, whatever I highlighted in green are the ones which are important to remember or memorize, not immediately, but later down the line once you keep practicing about HL7 implementations. You'll be habituated to memorize them, but greens are the one which are usually or commonly conversed during an interface implementation. So from my experience, I have highlighted all the fields which we usually talk about during any new interface implementation with some vendors. So we have to keep them in mind. So for example, if someone says I'm sending application MSH3, sending application with so and so value, then we need to immediately hit in our mind that sending application is MSH3 and I need to take a look at the message uh, at MSH3 to understand what is being sent in the HL7 message. So that is the significance of these fields which are highlighted in green. Let us quickly take the look of the table, understand the structure of the table, and then we will take a look at the segments. So the first one is a sequence, which means it is showing which field number of the segment we are taking a look at. MSH 1, 2, 3, and so on. So we have many fields, but we won't be going through each and every one because not each and every field is important. So the ones that are highlighted, I'll give you an explanation how and why they are important and all. And the second segment is length. So length determines how much should be the length of the data that is present within a particular field. If it is giving some number, it means that it is limited to that number. Okay, if it doesn't have any number, then it can be of any length. So for example, MSH 3, 4, 5, 6, all of these are showing up as 0, which means it can have any length. But MSH2 has 5 as the uh, 5 as the limitation, which means it cannot have more than 5 data fields or 5 letters or 5 words. And then we have the third column, which is DT, which is data type. So in any programming language, we usually have data type, right? Which we represent what kind of data is present within the what kind of data is being dealt with while writing the program, or while creating new variables and all. So in the same way, in even in HL7, we have different data types. There are around 89 data types in HL7 version 2.7. We will be covering most of them, mostly half of them, to go through in the upcoming sessions. So it is a different topic altogether, data types. So we'll be looking at data types once we complete all the segments and message types and fields. Then that is when we'll come back to data types. Next column is optionality. It will represent whether something is required, something is optional. If it is R, it means that it is required. If it is O, it means that it is optional. You will also see other indications within this particular field, which are like W. W means withdrawn. What does withdrawn mean? So currently we are going through HL7 specifications 2.7 version. Okay. So when you see something as withdrawn, it means it is withdrawn in HL7 2.7. However, it was in use in the previous version, HL7 2.5 or 2.3. So that is what it means if you see W. If you see B, which means backward compatibility. Okay. So this field, wherever for whichever field you see it as B, it represents that it is there in that particular placeholder for backward compatibility, so that if anyone else is using that field in HL7 version 2.7, that could be supported. Next one you see C, sorry. Next is you will see C, which is conditionally required. So as the name itself suggests, based on certain conditions, the data within that field might be important. So it is not always required. It is conditionally required, and that condition could be on any other aspect of the HL7 message. So based on that, we will have these things. Other two things are which we already saw, which is one is required and other one is optional. Okay. In this way, we have 5 different notations in the optionality column. Next is repetition. So it is telling us how many number of times certain field can be repeated. Okay. We will take a look at repetitions when we are talking about a demographic message, when we talk about PID segment in detail. But apparently, repetition means whether some field within the HL7 can be repeated or not. That can be indicated with the help of the repetition column. Next, we have table column. So this table column is nothing but um, it will have list of tables that has to be used from HL7 standard perspective. Okay, I will give you one good example. Let us say we have gender. Okay, in PID segment we have gender. So we'll take a look at when we get there. Apparently, it represents data fields and data values. HL7 defines those data fields and data values, and we are supposed to use the data from that table for any specific field. For example, here you are seeing table number 361, which means HL7 has defined that data in this field should go in specific format or the values that are present in this table. Okay, we'll take a look at real-time example. That is when you'll get a clear picture of what an HL7 table is. And the last one is the name of the field, name of each and every individual field, which is pretty much understandable. We'll take a look at them one by one. So this is the table structure. We'll be following the very same structure throughout the training for all the message types, for all the segments and fields. And again, in each and every segment, I have highlighted the important values in green, so you can memorize them. So we'll jump to the individual fields. MSH1 is field separator. MSH2 is encoding characters. We have little exception here. Only MSH segment has little exception. Apart from that, any field will not have this character. So what is that? When you look at an HL7 message, you will see that we have different fields. And when we looked at our sample example yesterday, we did saw that each segment is divided into fields, which are nothing but compartments. And the fields are read as this is field number one because this is EVN segment, and this is the first compartment, second compartment, third, fourth, and so on. So this is first field, this is second field, third field, fourth field, and fifth field, and so on. However, only for MSH value, the first MSH1 is just the pipe, only the pipe. Only one single pipe is called as MSH1, and rest of them remain same. This is MSH2, this is MSH3, MSH4, and so on. Only MSH1 is an exception where you will have just the pipe read as number one, and further fields, whatever is held between two pipes, are called as fields. So this is pipe num this is we have two pipes here, and within this we have MSH2, and then we have two pipes here. Within this, the data is called as MSH3, and so on. So that is how we read it. Only MSH1 is an exception in the entire message. So MSH1 has field separator, and then MSH2 has encoding characters. So these are encoding characters, right? Nothing but the grammar that is used by HL7 language. So in HL7 language, we have its own syntax and grammar, which we did take a look at yesterday. So it indicates that we are going to use this grammar down the line in the HL7 message. That is what the representation is for. Next, we have MSH3, MSH4, 5, and 6. These four fields are very, very important and play a major role while communicating with another system electronically. So what are those fields? MSH3 is sending application, MSH4 is sending facility, which means when we deal with an HL7 message, we are always talking in terms of transacting a message from one system to another system, right? It is always going from one system to another system. If that scenario is not applicable, we don't need HL7 message at all. We don't even generate HL7 message at all. Whenever there is necessity of sending data from one system to another system, that is when we will go ahead and generate an HL7 message, right? So apparently to represent that information, we need some placeholders within the HL7 message segment in order to see that information. So that information can be seen in message 3, 4, 5, and 6. 3 represents sending application, which means which application is going to send an HL7 message. 4 represents sending facility, which is nothing but which facility or which location this message, this particular HL7 message is being sent from, is represented in a message 4. Then we have a message 5. A message 5 represents receiving application, 6 represents receiving facility. So receiving application will have receiving application information. For example, if we take an example of PM and EHR, let us say demographic message is going from PM to EHR. So sending application would be the PM application, and sending facility would be the hospital location or hospital clinic location. And then we have MSH 5 and 6. MSH 5 is receiving facility, MSH 5 is receiving application, which is the EHR application, and MSH 6 is receiving facility. If it is same like the PM systems facility, then we'll have the same information here. However, 3 will have PM, 5 will have EHR, because these are two different applications that are in transaction right now. So with the help of these, someone will be able to tell where the message is getting originated from and where it is being sent. Okay. And then next we have date and time of the message, MSH7. So this is also very, very important, which is mainly used for tracking purposes to see when the HL7 message got generated. So at times we might have some disputes that there is a delay in sending out the message from our system to the destination system. So when such arguments come up, we usually take a look at message 7 to determine when exactly we are sending the message, at what point of time it is getting generated. Okay. So if there is any performance lag, usually what happens is message gets generated little later than the point of time when it got registered. That is one scenario. Another scenario is like message gets generated at the same time as soon as the patient gets saved in the system. However, it will take time, at least 2 to 3 minutes at times, to send out the message from source system to the destination system. So that is also a problematic scenario, because whenever there is any new patient registration, it has to be immediately sent out from PM to EHR. If there is a delay, then all the messages will get queued up on the HR side. And if that scenario happens, doctor will not know who are the patients that are visiting today. Okay. So that is the significance of MSH7. We usually use it in troubleshooting and also and also for tracking purposes. Then we have MSH9, which is message type. So as I did show in the example, this is the message type which we use. We always concatenate with the name message type, which is MADT, and as a whole we call it as a message type ADT A08, ADT A04, ADT A28, and so on, SIUS 12, and so on. Next we have message 10, which is message control ID. Message control ID always, it is called as a unique ID for each and every message. So every patient that gets registered in the PM system will have a unique patient MRN number, right? They don't assign or allow duplication of patient IDs. In the similar way, MSH10 represent message control ID, which is the unique ID to identify each and every message that is transacting between two different systems. And this is also used for tracking purposes, which is the primary thing. Second is to track acknowledgements. So what is tracking of acknowledgements? Why do we need to track acknowledgements? We'll talk about that later when we get into acknowledgement message types. But all that we need to remember right now is message control is the ID is used to identify individual messages. That is first point. And second point is it is also used for matching up while receiving an acknowledgement message. Okay, next, MSH11 is processing ID. So this ID will help us to determine whether any message that we receive or send is actually a um, is actually a production message or a development related message or a test message. So usually you'll see three values here in MSH11. One is P as in Peter, D as in Delta, which is for development, and T as in test, which is usually for testing. So in production, we should always have P, which represents a production message. But in case of testing, which we usually do while implementing an interface, then you can have T or D as the values. Okay. And then next we have MSH12. MSH12 is version ID. It is nothing but the version ID of the HL7 that we are using. If it is 2.3, we show it as 2.3. Then if we have 2.45, we represent in the similar manner. Then next we have MSH 15 and 16. So what is MSH 15? Accept acknowledgement. MSH 16 is application acknowledgement. Before looking at them, we need to understand what an acknowledgement is. Let us say, for example, you are going to a textile showroom, you purchase something, some clothes, and at the billing counter, you pay the bill and take a receipt. So why do we take that receipt usually? That receipt represents that uh, we have paid the bill to the owner of that particular shop or particular mall. In the same way, in an HL7 transaction, whenever a message is sent from one system to another, the receiving system should always respond back with a receipt. So that receipt is called as an acknowledgement. So that the source system or the sending system can understand that the message has been delivered successfully to the destination. Let us say now PM to EHR. When PM is sending out a demographic message to EHR, EHR, once it receives that demographic message, it will send out an acknowledgement back to the PM system. Okay, that is called as an acknowledgement. And having an acknowledgement is very, very important because that will let the sender know that message has been delivered successfully to the destination site. So we have two different types of acknowledgement. One is accept level acknowledgement, another one is application level acknowledgement. So what does accept level acknowledgement mean? It means that as soon as the message is hitting the destination, it will immediately go ahead and send out a reply back to the source system without any delay. That is called as an accept acknowledgement. It will just tell the system that I have received the message and um, this is the proof that we have received the message. So that is what MSH 15 accept acknowledgement represents. When we come to application level acknowledgement, the acknowledgement is not sent immediately back from the HR system. It will look at the specifics of the HL7 message, whether standards are followed, whether all the segments are required segment are present or not, whether all the required fields are present or not. All of this validation of HL7 message happens. If everything is right, that is the only point when it will send out an application level acknowledgement. So again, I will repeat it. We have two different types of acknowledgement. One is accept acknowledgement, another one is application level acknowledgement. Accept acknowledgement is sent as soon as the message is received. It will not validate whether all the segments, required fields, required segments are present or not. It will just see that a message is received and it will respond back. However, with application level acknowledgement, it will take a deeper look at the message it is receiving. It will validate if all this required segment of that message are present, all the required fields of the message are present or not. Once these two are determined, it will go ahead and send out an acknowledgement back to the PM system. So that is the significance of these two. We'll talk about this in detail with the help of a diagram when we come to understand or when we come back to the point where we will be talking about acknowledgement message types. Okay. So next we have other segments. So we'll be going through other segments tomorrow. That is all for today's session. Any questions, guys? Do you have any questions that you want me to help you with? All right. So I'm not hearing anything. I I will consider that as a no. So Srinivas will go ahead and share a drive, Google Drive with you, where we'll be uploading these documents, and you can go through these documents and PPT that we are going through during these sessions. Okay, and thank you so much for joining today. We'll have the next session tomorrow morning at the very same time, and you all have a good day.
Thank you.
Hi, Sudhakar. How can I help you?
I just wanted to check, are you going to be covering HL7 fire as well here in these sessions? Like the
No,
fire
I'm
structure? Is it only
no. We'll
V2?
sorry.
Is this only HL7 V2?
Yes, only HL7 V2. In the
Okay.
last session, I'll be giving a bird's eye view of what is FHIR and what are the different resources that we have, how we
Mm-hmm.
can, what is the structure of. We'll be just checking one of the resource, but not an in-depth training on HL7 FHIR or HL7 CCDs as well. I'll be just telling you why do we use CCDs, where we use CCDs, and where we use
Mm.
FHIR, and little overview on that, but not as in depth as HL7.
Okay.
This
Uh,
training is only for HL7 V2 and Mirth Connect integrations. How we generate HL7 messages with the help of Mirth Connect, how do we interpret them and import them into the database and all of these things.
got it. All right. Thank you.
You're welcome.
All right then. Thank you, Dixon.
Yeah.
I'm going to
Thank
drop
you.
off. Thank you.
Yeah, sure. Thank you. Thank you, everyone. You all have a good day.
All right. You too.